Hello, everyone.
Hello.
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 And good day, Engineer Ponsalan. And I'm Dan, and we're here to discuss the natural gas power plant, its history, equipments, operations, economics, and advantage and disadvantages of it. The natural gas was discovered accidentally in ancient China, as it resulted from the drilling of brines. Natural gas was first used by the Chinese in about 500 BC, or possibly even 1000 BC. They discovered a way to transport gas sweeping from ground in crude pipelines of bamboo to where it was used to boil salt water to extract the salt in district of Sichuan. The discovery and identification of natural gas in Americas happened in 1626. In 1821, William Hart successfully dug the first natural gas well at Fredonia, New York, United States, which led to formation of Fredonia Gas Line Company. The city of Philadelphia created the first municipality-owned natural gas distribution venture in 1836, and by 2009, 6,600 or 66,000 kilometer cubic, 6,600 cubic meter or 8% has been used out of the total 850 kilometer cubic or of estimated remaining recovered reserve of natural gas. Based on estimated 2015 world consumption rate about of 3,400 cubic kilometers of gas per year. The total estimated remaining economically recoverable reserves of natural gas would last 250 years at current consumption rates. An annual increase of usage of 2 to 3% could result in current recoverable reserves lasting significantly less, perhaps a few 80 to 100 years. And in the Philippines, we also have the gas-fired power plant, the 414 megawatt San Gabriel combined cycle natural gas-fired power plant. It is located in Santa Rita, Batangas City in the Philippines, as I mentioned, developed with the estimated cost of $600 million. The power plant is owned and operated by the First Gas Power Corporation, or also known as FNTC, a wholly owned subsidiary of the First Gen. The construction of power plant began in 2014, while the commercial operation started in November 2016. The generated power is fed to the power grid in Luzon. The power plant experienced an outage after a trip in September 2020. The internal investigation by the Siemens Power Operation indicated that the trip was caused by a fault in the generator of the plant's Unit 70, which activated the generator protection. But the plant remained offline for just 5 months and restarted the operation in January 2021. The following successful completion and the generator repairs and reclamation activities makes the power plant blue. So that is all for the history and introduction of natural gas power plant. So the next will be the equipment.
I am CLYDE CADIZ, and I will be discussing the equipment of natural gas power plant. So for the natural gas power plant, its equipment offers the efficient repair and maintenance services for rotating equipment like gas turbines, compressors, pumps, and generators. Its pumps covers applications from boiler feed to condensate extraction. It produces critical turbine components. So for the gas turbines, it is a combustion engine at the heart of a power plant that can convert natural gas or other liquid fuels to mechanical energy. This energy then drives a generator that produces the electrical energy that moves along power lines to homes and businesses. Next equipment is a compressor. It is a mechanical device that increases the pressure of a gas by reducing its volume. So an air compressor is a specific type of a gas compressor. And the third equipment is a pump. A pump is a mechanical device that uses to transfer different fluids from one location to another. It is a hydraulic device that lifts fluid from low to high levels. It also moves fluids from low to high pressure areas. Also, the pump transfers fluid by converting the fluid's mechanical energy into pressure energy. And lastly, the generator. A generator is a device that converts motive power or the mechanical energy into electrical power for use of external circuit. And that's all about the equipment of natural gas power plant. Thank you.
I'm Ruperto and TORRES, and I will discuss about the operation of natural gas power plants. Natural gas power plants generate electricity by burning natural gases as their fuel. There are many types of natural gas power plants which all generate electricity but serve different purposes. All natural gas plants use a gas turbine. Natural gas is added along with a stream of air which combusts and expands through this turbine, causing a generator to spin a magnet, making electricity. There is a waste heat that comes from this process. Because of the second law of thermodynamics, some natural gas plants use this waste heat as well, which is explained. Natural gas power plants are cheap and quick to build. They are also very high thermodynamic efficiencies compared to other power plants. Burning of natural gas produces fewer pollutants like nitrogen oxides, sulfuric oxides, and particulate matter than coal and oil. While on the other hand, natural gas plants have significantly higher emission than a nuclear power plant. This means that air quality needs to improve. When switching to natural gas plants, the coal plants, but nuclear power does not even more to improve air quality. So despite the improved air quality, these natural gas plants significantly contribute to climate changes, and that contribution is growing. Natural gas, however, produces considerable carbon dioxide, although less than coal plants do. On the other hand, the process of getting natural gas from where it's mined to the power plants lead to considerate release of methane. As long as natural gas plants are used to produce electricity, their emission will continue to warm the planet in dangerous ways. So, natural gas turbines are theoretically simple and not flaming parts. So these are the compressor, combustors, and turbine. Now we have firstly compressor. Early gas turbines employed centrifugal compressors, which are relatively simple and inexpensive. They are, however, limited to low pressure ratios and cannot match the efficiencies of modern axial flow compressors. Accordingly, centrifugal compressors are used today primarily in small industrial units in axial flow turbines. The blade passages, which look like twisted, highly curved airfoils, must exert a tangential force on the fluid, with the pressures on one side of the blade higher than the other. For a subsonic flow, an increase in pressure requires the flow area to also increase, thus reducing the flow velocity between the blade passages and diffusing the flow. So a row of compressors blade must be viewed as a set of closely spaced, highly curved airfoils shaped with spade, which airflow strong interacts. So there will not only be a rise in pressure along with the blades, but a variation between between them as well. So flow friction leakage and secondary circulation of soil flows all contributes to the losses of a real unit. So the test of stationary blades assembles, known as cascades, can be performed in special wind tunnels, but actual blades arrangement in a rotating assembly require special test setups for rigs. And the next we have is the combustors. The air leaving the compressors must first be slowed down and then split into two streams. The smaller stream is fed centrally in a region where atomized fuel is injected and burned with the flame held in the place by a turbulence generating place obstruction. The larger cooler stream is then fed into the chamber through hose along a combustion line to reduce the overall temperature to a level suitable for the turbine inlet. So combustion can be carried out in a series of nearly cylindrical elements spaced around the circumference of the engine called cans, or in a single annular passage with fuel injection with various circumferential positions. The difficulty of achieving nearly uniform exit temperature distribution in a short aircraft combustion chamber can be alleviated in stationary application by the longer chambers with partial interval reversed flow. And lastly, for the turbine. It is normally based in the reaction principle with hot gases, expanding through up to 8 stages using 1 or 2 spool turbines. In a turbine, driving an external load part of the expansion frequently takes place in a high-pressure turbine that drives only the compressor, while the remaining expansion takes place in a separate, free turbine connected to the load. And that is for the simple cycle stops. So after the simple cycle, we have the combined cycle. So a combined cycle power plant uses both gas and steam turbine together to produce up to 50% more electricity from the same fuel than a traditional simple cycle plant. So the waste heat from the gas turbine is routed to the nearby steam turbine, which generates extra power. So how do combined cycle plants works to produce electricity and captures waste heat from the gas turbine to increase efficiency and electrical output? First, we have is the gas turbines burns fuel. So the gas turbine compresses air and mixes it with fuel that is heated to a very high temperature. The hot air fuel mixture moves through the gas turbine blades, making them spin. And then the fast spinning turbine drives a generator that converts a portion of the spinning energy into electricity. The next we have is the heat recovery system captures exhaust. A heat recovery system generator captures heat from the gas turbine that would otherwise escape through the exhaust stack, also known as the HRSG. It creates steam from the gas turbine exhaust heat and delivers it to the steam turbine. And last is the steam turbines deliver additional electricity. So the steam turbine sends its energy to the generator drive shaft, where it is converted into additional electricity. So that is for the combined cycle. And lastly, we have the cogeneration. So the cogeneration, also known as combined heat and power, distributed generation, or recycled energy. It is the simultaneous production of two or more forms of energy from a single fuel source. Cogeneration present higher efficiency rates than single generation facilities. So in practical terms, what cogeneration usually entails is the use of what would otherwise be wasted heat to produce additional energy, such as provide heat or electricity for the building in which is operating. Cogeneration is great for the bottom line and also for the environment, as recycling the waste heat saves other pollutants spewing fuels from being burned. Natural gas plants produce waste heat like all heat engines. Sometimes this waste heat is captured for industrial uses. So that is for the cogeneration process.
gas power plant is a thermal power station, which burns natural gas to generate the electricity. Gas power plant or natural gas power plant works on Brayton cycle to generate the electricity. Natural gases play big role for generating electricity. This plant is more flexible for power generation. It's more efficient per ton of fuel. Today electricity is playing very important role for run the world. We needs for lighting our homes, school buildings, factory, town, shopping mall and public places. Electricity also used to run industries, railway station, metro, airport, cinema hall, air traffic control and construction sites, etc. Electricity generated using natural gas turbines was first produced for public use 1939 to 1940 at a plant in Neuchâtel, Switzerland. The Central Electricity Authority. The total installed capacity of gas-based power plant in India is 17,706 megawatt. Gas power plants generated 7.21% of India's electricity. Gas-fired power plant or natural gas power plant is a thermal power station, which burns natural gas to generate electricity. Natural gas power plant generate a quarter of world electricity, and significant part of global greenhouse gas emissions like carbon dioxide, methane, nitrous oxide, ozone, and water vapor. Gas power plant is type of fossil fuel power plant in which chemical energy stored in natural gas, which is mainly methane, is converted successful into thermal energy, mechanical energy, and electrical energy. All natural gas power plants use a gas turbine. Natural gas is added, along with the stream air, which combusts and expands through turbine, causing a generator to spin a magnet, making electricity. The turbine is used to drive a synchronous generator which produces the electric power. Because the turbine normally operates at very high rotational speeds of 12,000 rpm or more, it must be connected to generator through a high ratio reduction gear, since the generators run at speeds of 1000 or 1200 rpm depending on the AC frequency of electricity grid. Gas turbines have three main parts. Number 1, compressor takes in air from outside of the turbine and increase its pressure. Number 2, combustor burns the fuel and produces high pressure and high velocity gas. Number 3, turbine extracts the energy from the gas coming from the combustor. There is waste heat that comes from this process. Some natural gas power plant use this waste heat as well. There are two types of natural gas power plant. One is simply cycle gas power plant and other is combined cycle gas turbine power plant. Simple cycle gas turbine power plant, also known as open cycle gas turbine power plant. Hot gas drives a gas turbine to generate electricity. This type of plant is relatively cheap to build and start very quickly, but due to its lower efficiency. Simple cycle gas turbine power plant are able to dispatch faster than coal-fired power plant. They are turned on or off faster in order to meet society electricity needs often needed on the grid. Fluctuating electricity needs of society known as peaking power. Combined cycle gas turbine power plant consists of simple cycle gas turbine, which use the Brayton cycle followed by a heat recovery steam turbine and generator. which use the Rankine cycle. The most common configuration in 2 gas turbines supporting 1 steam turbine. They are more efficient than simply cycle plant and can achieve efficiency slightly over 60%, and dispatch times of around half an hour. It makes use of the hot exhaust gases that would otherwise be dispelled from system. These exhaust gas used to boil water converted into steam, which can then spin another turbine and generate the electricity. It is more efficiency. These plant produce 1/3 of the waste heat of plant with a 33% of efficiency like coal and nuclear power plant. Burning of natural gas produces fewer pollutants like nitrogen oxides, sulfur dioxide, and various gases and matter than coal. On the other hand, natural gas plant have significant higher emissions than a nuclear power plant. This means that air quality tends to improve, reduce smog. When switching to natural gas plant from coal plant. But nuclear power does every to improve air quality. Despite the improved air quality, natural gas plants significantly contribute to climate change. On the other hand, the process of getting natural gas from where it's mined to the power plant lead to considerable release of methane. As long as natural gas plant are used to produce electricity, their emission will continue to warm the plant in dangerous ways.
That is all for the operation of natural gas power plants.
My name is CABALAN, and I'm discussing the economics of natural gas power plants and the topics that follows. So first, I'll talk about the natural gas power plant price. Second, I'll talk about the factor to consider is the length of time it will take to construct a natural gas power plant. The third question is, how much does a natural gas power plant cost per kilowatt per hour? And the fourth is, how much does a natural gas power plant cost per YOR or yield of return? So let's start with the natural gas power plant's price. A natural gas power plant or natural gas power plants have been a major source of expanded grid capacity in recent years. Natural gas power station installed 6,549 megawatts of capacity in 2015. The construction cost for natural gas power plants in the same year average of $812 per kilowatt, making the total of $5,318,957 for 74 generators. In addition, natural gas power plants use 3 different kinds of technology. The total building costs are influenced significantly by each technology. Internal combustion engines accounted for only a minor portion of the capacity installed, with combined cycle natural gas power plants of 4,755 megawatts and combustion turbines of 1,553 accounting for the majority of 240. The second one that I will discuss is the length of time it will take to construct a natural gas power plant. The great majority of power plant projects nowadays are EPC, which means they are engineered, procured, built, and completed in as little as 28 to 30 months to accomplish customer needs. So when we say engineering, procurement, and construction or EPC, we're talking about companies that provide a full package of services to help infrastructure projects be completed. EPC services often give a single point of contact for project execution, reducing risk for the owner. The third one that I will discuss is how much does a natural gas power plant cost per kilowatt hour? According to the new Hamilton Project document, the total cost of power generated by a natural gas plant is about 6.5 cents kilowatt per hour. This is over a quarter of the cost of electricity generated by existing coal plants.
The fourth one that I will discuss is how much does a natural gas power plant cost per YOR or yield of return. The yield of return or YOR is the amount of money earned over time by an investment, usually given as a percentage. The overall cost of constructing a natural gas power plant is split by the amount of electricity sold to consumer by the power plant. But here, we were unable to obtain the exact YOR or yield of return of the natural gas power plant because some natural gas power plant data is classified as confidential. So that's all for the economics of natural gas power plants.
My name is Jason Gabriel Acaber, and I'll be discussing the advantages and disadvantages of natural gas extraction. So natural gas is one of the cleanest fossil fuels, releasing 45% fewer carbon emissions than coal and oil. The United States is flooded with natural gas with enough to last the rest of the century given 2018 production rates. EIA says that there were 2,276 trillion cubic feet of technically recoverable, dry or consumer grade natural gas resources in the US in January 2013, with total proved reserves of gross natural gas worldwide at 6,846 trillion cubic feet. One of the advantages is it does not produce waste products such as coal ash, as its byproducts are in gaseous form. Natural gas burns cleaner than gasoline and diesel. It releases 45% less carbon dioxide than coal and 30% less than oil, and has therefore an overall smaller impact on the environment. If there's a gas leak, it disappears quickly into the air, whereas oil leaks have a devastating impact on the environment and are expensive to clean. Also, since the process of natural gas combustion is almost up to the mark, the level of byproducts disseminated to the environment is minimal. So natural gas beats out other fossil fuels when it comes to being a clean burning energy source. Gas can be easily transported through pipelines, direct to industry and residential properties. There are considerable reserves of gas around the world. In addition, since natural gas elevates any need for an underground storage tank, it eliminates potential soil contamination, oil spills, and anticipated cleanup of the environment. Also, gas can be used for both heating and cooking. So what are the disadvantages of natural gas extraction? So gas is highly flammable, which means leaks can result in explosions. As with other fossil energy sources, natural gas is a limited source of energy that will eventually run out. Although it is a non-renewable and unsustainable energy source, it can still play an important role in the long-term sustainability of our planet. Natural gas can be used to advantage as a cleaner alternative for oil and coal until renewable energy dominates the energy mix of the world. And also, one of the disadvantages is natural gas is toxic. While natural gas is easier to store and transport, its volume is 4 times that of gasoline, so natural gas producers have to spend more time on storage. This is by far the biggest disadvantage of natural gas. So to use natural gas, all of the components, except methane, have to be extracted. So this results by products such as hydrocarbons, sulfur, water vapor, carbon dioxide, and even helium and nitrogen. So gas infrastructure is expensive. Pipelines cost a significant amount of money to construct. Natural gas has both advantages and disadvantages. So despite the cons, natural gas remains one of the most inexpensive and easily available fossil fuels in this world, and can serve as a viable alternative to one of our fossil fuels until something more efficient can be found. Unless an odorant is added to the gas, leaks can go undetected. And also earthquakes have been caused by the controversial process of fracking. So natural gas is an arguably a growing industry, and with the further developments in technology is one that can certainly help pave the way to the sustainable future. And also the last one is burning natural gas results in the release of greenhouse gases, particularly carbon dioxide. So that's all.